Okay, so 912, this is our last lesson for this week. Tomorrow you'll have more practice on the same lesson. So 912 is solving quadratic equations using the quadratic formula. So example 1, if we try to solve x squared plus 4x minus 3, we cannot find perfect, we're going to try to factor, okay? So let's try this out. So factor, we do first times last is -3, middle is 4. What multiplies to -3 and adds to 4? And you might say, well, what about -3 and -1? But that makes -4 and it doesn't make -3. And then you can say, oh, what about 3 and 1? That will make 4, but that doesn't give me -3. And then I don't think of any other numbers that multiply to 3 except for 3 and 1. And no matter what combination I get, I can't get the signs to work. So we cannot find perfect integers. However, if we look at the graph, we know that it has solutions because we can see it crosses here and here. Okay. So to figure out these solutions, we're going to use what we call the quadratic formula. And you do not need to memorize this formula, but you're going to be using it and need to understand what it's doing. So the quadratic formula is an equation in standard form, ax squared plus bx plus c equals 0. So you always have to put it in standard form. And then we're going to plug into this formula. And if we solve this carefully using order of operations, B goes here and here, A goes there, and C goes there. If you solve it carefully, you will get the solutions to the equation. Whether they're perfect squares or non-perfect squares, whether they're whole, whether they're fractions, whether they're not real, you will get the answer. So in the expression, what is A, B, and C? So A is a number in front of the x squared, which is 1. B is a number in front of the x, which is 4. And C is the last term, which is -3. So now we're going to plug it in. So remember, it's -b. So 4 goes here. I like to put parentheses anywhere I substitute. And then here is 4b again, squared. 4 times a, which is 1, times c, which is -3, over 2 times a, which is 1. So we're plugging in our values following what letters it tells us here. And then we have to be very careful with order of operations. Every time it's the same process, but we have to make sure we're careful. So the first thing we're going to do is make this 4 negative. So we have -4. Then we put a plus and a minus. That means we're going to add and subtract the value. 2 separate answers. We'll do that at the end. Inside the radical, we have a squared, we have a subtraction, and we have some multiplication. So exponents come first. 4 squared is 16. Okay? And then after we do our exponent, we're going to multiply all of these numbers together. -4 times 1 times -3. -4 times 1 is -4 times -3 is +12. And we're going to either put plus or minus. If it's positive, plus 12. If it's minus, minus 12. And then the whole thing goes over 2 times 1, which is 2. Next step in order of operations is to finish doing the radicals. So we have -4 plus or minus 16 plus 12 is 28 over 2. This is where the simplifying radicals we learned about yesterday is going to be really important. Because now on the side, we're going to take the square root of 28 and we're going to simplify it. So we break that down, 2 times 14, and then 14 is 2 times 7. The 14 is simplified. We have this pair, like we were looking at yesterday, pair of 2's. So that would be the square root of 4, which is 2 root 7. So that is our simplified answer to the root 28. So now we're going to go from this step, we're going to write -4 plus minus, and we're going to write 2 root 7, and then the whole thing is over 2. So we're taking the 28 and we're replacing it with the simplified version. Now we have 2 answers here, so we're going to write them separately. We're going to write x equals, start with the -4, and we're going to do the plus 2 root 7 over 2, and then we're going to separate one, x equals -4, instead of plus, we're going to use a minus this time, minus 2 root 7 over 2. So now the last thing to do is simplify. Because we're dividing by 2, 4 and 2 are both divisible by 2, we're going to do this. -4 divided by 2 is -2. 2 divided by 2 is 1 root 7. So that's the first answer. We know there's always two answers. The second answer, x equals negative 4 divided by 2 is negative 2. Negative 2 divided by 2 is negative 1 root 7. And we have our two answers. Okay, so every time, same process. The numbers might be different, but we're doing the same process. We plug in the numbers to the equation. We simplify this exponent. We multiply the other three numbers together. We add or subtract. We simplify our radical. And then we split. And then we simplify each part. So let's look at the next example. Okay. It says the following examples will produce integer solutions, which match the solutions you get if you factor. So if you did want to check these, you could factor and solve and make sure they're the same. First thing is to make sure our equation is in standard form. So we need to keep the x squared where it is, the minus 12x where it is, but we need to add 20 and make it equal to 0. So we have to get in standard form. And then we need to say what is a, b, and c. A is 1. B is negative 12. And c is 20. So we found our values. Now let's plug it in. Negative b. So remember, always use parentheses. So negative 12, negative 12. 4 times a is 1 times c is 20 over 2 times a, which is 1. So now we're going to simplify this. Negative 12 makes 12 plus or minus. Negative 12 times negative 12 is positive 144. And then we multiply this all together. Negative 4 times 1 is negative 4 times 20 is negative 80. Over 2 times 1 is 2. So then we simplify inside the radical. 12 plus or minus the square root of 64 over 2. Hopefully at this point you realize the square root of 64 is a perfect square. So we're going to replace, keep going. We're going to keep the 12 plus or minus the square root of 64 is 8 over 2. Once we have that radical simplified, we're going to write our two expressions. So x equals 12 plus 8 over 2. And the second equation is x equals 12 minus 8 over 2. 12 plus 8 is 20 over 2, which is 10. 12 minus 8 is 4 over 2, which is 2. So we have our two answers to the equation. So now let's look at example 3. Again, we need to move the 18 to the other side. So we have 2x squared plus 9x. We're going to minus 18 equals 0. So A is 2, B is 9, and C equals negative 18. So substituting in negative B and then B squared, 4 times A times C over 2 times A. And then first step, simplify B, negative 9 plus or minus 9 squared is 81. And then if we multiply this all together, negative 4 times 2 is negative 8. And then negative 8 times negative 18 is positive 144. Over 2 times 2 is 4. So now we simplify negative 9 plus or minus the square root of 81 plus 144 is 225 over 4. And then if we check the square root of 225, hopefully you know, but if you don't, is 15. So again, we're taking the square root of 225, which is 15, and then that's over 4. So now is when we split it up. X equals negative 9 plus 15 over 4. X equals negative 9 minus 15 over 4. Negative 9 plus 15 is 6 over 4. So x is simplified 3 over 2. And then negative 9 minus 15 is negative 24 over 4. So x simplified is negative 6. And then the last example, solve each equation using the quadratic formula. You will not get perfect integers. Simplify the radicals. So we're going back to using the same idea. These are, the fill-in part is not there, so you've got to kind of think about filling it in yourself. So this is in the right form. A equals 3, B equals -2, C equals 9. So the formula is negative B, so we're going to plug in B, plus or minus the square root of B, which is -2 squared, minus 4 times A, which is 3, times C, which is 9, over 2 times A. And if we simplify, -2 makes 2, plus or minus. -2 squared is 4. -3 times 4, -4 times 3 is -12. Times 9 is -108. Over 2 times 3 is 6. Simplify a step further, we get 2 plus or minus the square root of -104 over 6. And at this point, we're looking at the radical here. And any of you, hopefully you remember, you can't take the square root of a negative number. The square root of a negative number is not real, because when you think of square root, it's a number times itself. If we do a negative times a negative, we get a positive. So a negative times a negative is a positive. A positive times a positive is a positive. There's no way to get a negative by multiplying the same number by itself. So this is going to be not real. And if that's not real, then the solution is x is not real. When you get to Algebra 2 or in more advanced classes, you'll learn what to do instead. At this point, anytime you get a negative under your radical, the answer is going to be not real, and you can stop at that point. So let's look at B. B, we've got to get the 25 moved over to the other side. So we have 10x squared minus 5x minus 25 equals 0. Right? And then I look at this, and this is something you can do, and if you find it easier, if you see that all of these numbers are all divisible by the same, I say, oh, these are all multiples of 5, you can divide everything by 5 to give yourself easier numbers to work with. So I have 2x squared minus 1x minus 5 equals 0. And now A is 2, B is -1, and C is -5. Again, you can use the original numbers. A is 10, B is -5, C is -25. You'll get the same results. The smaller numbers to me are easier to work with. So now we're going to plug in negative B, which is -1, plus or minus square root of B, which is -1 squared, minus 4 times A is 2, times C is -5, all divisible by 2 times A. And then we're going to start simplifying. -1 is 1. -1 squared is 1. -4 times 2 is -8, times 5 is +40 over 4. And then we simplify further. We get 1 plus or minus the square root of 41 over 4. And then because we have a radical, remember we simplify. So what's the square root of 41? And then we try to break this down. 41 is actually prime, so it won't simplify. So now, because we can't simplify that, we're just going to get our two answers. X equals 1 plus root 41 over 4. And then x equals 1 minus root 41 over 4. And those are the two final answers. If you had used the original numbers here, you would have gotten to a bigger radical, and then you would have been able to simplify down to this. Okay? But if you simplify first, if every number is divisible by the same number, and you simplify first, it makes the math much easier, and you don't have to simplify at the end.